This first demonstration will show the capability of the radio communication system. The left side of the screen shows the physical system. The bottom right of the screen shows the console printing the output of the base station. The top right of the screen shows the experiment's title card. The physical system consists of the base station in the top left, the simulated rover, circuitry in the bottom right, and the rover's solar panel in the top right. For the entirety of this portion of the demonstration, the base station will be periodically transmitting a CA command to the rover, which requests the rover to acknowledge the message and return an acknowledgment message along with the onboard battery level. This command transmission occurs every 5 seconds for the demonstration, but would be far less frequent in a full-scale lunar system, likely every 5 minutes to limit power consumption. The rover responds with a message in the format AA with 2 digits, meaning acknowledged are you there, where the digits is the measured battery level on a scale of 0 to 100. Transmission is shown by the red LED flashing on the base station. The return transmission is shown by the red LED flashing on the rover. The red LEDs flash any time the radios send or receive a message. Since no battery is currently integrated into this system, the battery level is simulated using a potentiometer and indicated by the green LED on the rover. The yellow LED indicates the simulated solar panel reception level from 0 to 100, controlled by another potentiometer. The console shows the timestamped messages being sent from and received by the base station. The base station sends the CA or command acknowledge message. The base station then receives the return message from the rover, the radio node from which it originated, and the transmission strength or RSSI in decibels. The following line translates the message and outputs an understandable message. Reducing the battery level is shown here. The battery drops and is eventually set to 0. The green LED's brightness is accordingly lowered and turns off at 0 power. I am using a 10K potentiometer to represent both the solar cell and the battery, with the output being converted to a 0 to 100 scale. This demonstration will show the battery level and laser power reception detection functionality of the rover system. Every second, the measured battery and laser power reception levels will be output to the console. As previously mentioned, the green LED represents the battery, and the yellow LED represents the solar array power received. The system is designed to keep the battery level between 20 to 80% capacity in order to maximize battery lifetime. Eventually, when the battery is set to 20%, the tracking system will be turned on and the laser will be pointed at the solar panel in order to charge the battery to 80%. This final demonstration of the radio system will show the battery level and solar array reception functionality of the rover system with an actual solar array wired in place of the simulating potentiometer. The power reception is still represented by the yellow LED. Covering the solar array reduces the reception to 0%. The reception of the ambient light is about 34%, and using a bright flashlight on the array increases reception.
This video is going to show the PTU actually running and capturing or targeting the IR LED. I'm now running the code, it's resetting, and now it is iteratively moving both the pan and tilt servos until it finds the IR LED. The screen now says that it has found the IR LED, and this green crosshair right here is the focus of the camera, and the circle is the identified IR LED.